We know that students need to practice the ideas and techniques that they're learning and receive feedback on that practice. Let's now talk about some instructional strategies for providing this kind of practice and feedback to students, and we'll start with a few that involve feedback from the instructor. Here's an example from a statistics course that I taught recently. I had taught this statistics course a few times and wanted to add a data visualization piece to the course this particular semester. I find that data visualization, interpreting data visualizations, creating data visualizations is an increasingly important component of statistics, and I wanted to prepare my engineering students to be able to at least make sense of complex data visualizations. So early in the semester, to get them involved in thinking along these lines, I had a class session where I shared with them some fairly sophisticated data visualizations of high-dimensional data sets, 4 or 5 dimensions of data on the same visualization. Then I gave them a fairly complex data set, one dealing with ecological footprint data for different countries. And I asked them to pair up and brainstorm some ways that they might visualize this data set. And so I asked them to get out a pen and paper and start to kind of doodle some ideas, thinking very intentionally about how they would represent different variables in the data set visually, either through color or size or other elements. And so after they had a few minutes to brainstorm, I asked them to get out their cell phones. They were actually a little bit surprised to hear that during class, but I wanted them to take photos of their doodles and then text or email those photos to me. What this allowed me to do, and this was a fairly large class. I had about 72 students in this course, and it was kind of hard to get around class, so it wasn't that practical to come around and kind of look at everyone's work. And instead, I had them, again, take out their cell phones and snap photos and send those photos to me. I was able to pull up pictures on the big screen and share some of the student work during class. Now, I would consider this an example of practice and feedback because the students had to practice some of their burgeoning data visualization skills to design these doodles. And I wasn't able to provide feedback to every student during class, but I was able to pull up some of the more interesting doodles, brainstorms that the students shared, share those back with the entire class, and offer some commentary. Here's a nice example of using size to represent this. This element of this visualization might be a little confusing given how you're using proportion, that kind of thing. And so all students got a chance to practice. Some students got very direct feedback on their work, but all students got to hear from me about some student work and get a form of feedback. Now, open-ended work like those doodles can be a great opportunity for practice. So can multiple choice questions. Here's a question from Patrick M. Lynn. He teaches astronomy at Cuesta College. Here's the question. Consider the view of the northeastern horizon shown at a certain date and time. Which of the following best describes the positions of these constellations 24 hours later? Answer A, slightly lower in the sky, closer to the northeast horizon. Answer B, exactly the same place. Answer C, slightly higher in the sky, farther up on the northeast horizon, etc. What this question asks students to do is to take what they know about the Earth's rotation in the night sky and apply it to this particular problem. It's a really nice example of kind of application level practice. Now, Patrick uses clickers with this question, and so he'll have students all respond A, B, C, D, or E, and then he'll have a nice bar graph on the big screen showing the distribution of student responses. Now, what Patrick can then do is, as he talks about the question and the answer choices, he's providing feedback to the students. They had the chance to kind of practice what they knew as they were answering. And as he talks through the correct answer, which happens to be C in this choice, the students who got the correct answer get some nice feedback, some confirmation that they understood it. But as he talks about some of the more popular wrong answers, the students who chose those answers get feedback as well. And so this is another example of giving students an opportunity to practice what they're learning in class and have the instructor provide a form of feedback to all students, perhaps more tailored feedback to some. Here's a third example. It's really great when you can do practice and feedback during class. It's a fantastic way to make use of class time, but sometimes the practice needs to happen outside of class. This is perhaps my all-time favorite use of Twitter in teaching. This is an example from Margaret Rebega. She's a biology professor at the University of Connecticut, and she teaches a course on ornithology, the study of birds. Now, this course fulfills a general education requirement, so it's usually a pretty big course, 75 or 100 students in it. One of her goals in this course is to have students connect what they're learning in class with the world outside, right? She wants them to understand that when they walk out the classroom door and they see birds, they can actually start to understand bird behavior, bird anatomy, things like that. And so what she does is she asks them each week to use Twitter to share observations of birds in the wild. So as they're traveling to class or going to work or going home, if they see a bird, they can pull out their cell phone and tweet an observation about that bird. They have to share where they saw the bird, they have to describe what they see, and then they have to also connect it to something that they're learning in class. They use a hashtag birdclass, which acts as kind of a key word, making it really easy for everyone to find these tweets. Let me share just a few to give you a sense of what the students are doing when they're out observing birds. The top one is from a student named Casey. She writes, "Saw a heron flying over Fenton River. Its large wings provide low wing loading for its body size. Good for flight." Hillary says, "Morbid, but saw a dead bird in my barn today. I'm guessing all the feather lice had already left." That may not have been Hillary's first reaction, but she's making a nice connection between what she saw and what she's learning in class. And then here's just a spectacular one from a student named Daniel. He's in East Longmeadow, Massachusetts. He writes, "Saw an albino red-tailed hawk. Lack of melanin really screws up your camouflage." And he actually managed to get a photo of this bird. Pretty amazing stuff. So again, the goal is for students to kind of transfer what they're learning inside of class to outside of class contexts. Margaret really wants her students to understand that, again, what they're learning in class, they can actually use as they're observing birds in the wild. Twitter is just a great medium for this. It allows students to just kind of take the cell phone that they already have in their pocket and write down some quick observations and share it. And so it's a really great opportunity for outside of class practice. In terms of feedback, what Margaret Rebega can do is, as the tweets are coming in, she can respond to individual students and give them a little bit of feedback, maybe adding a little extra information or clarifying their observation a bit. And then during class, she can, again, select a few tweets to share with the entire class and offer some commentary. One last example of feedback from the instructor. This is a practice that I adopted several years ago. I learned about it from one of my graduate school instructors, Mike Mahalik here at Vanderbilt. It's the idea of test corrections. And so here's kind of how this works in my class. When I hand my students back their midterm exam, they have the opportunity to do corrections on any problem where they miss points. So a week later, they turn in the exam, the original exam, along with full write-ups of any problems where they lost points. And they can earn up to a third of their points back. So if a student made a 70 out of 100 on the exam, that's a loss of 30 points. If they do all the corrections, they can get 10 points back and pull that up to an 80. What this does is it uses students' motivation to get good grades to really kind of motivate a behavior that they should be doing anyway. So typically a test is a kind of a, as we use the term, a summative assessment, right? It's meant to evaluate what students know and what they don't know. But ideally, especially in a math class or most STEM classes, students should be going over that first test they get back, figuring out what they did wrong, fixing their mistakes, because whatever was covered in that first test, the subsequent tests are going to build on that. So with my test correction policy, what I'm doing is I'm trying to motivate students to do that kind of review of the test, turning the test from a purely summative exercise to a formative assessment as well. So they start to get some feedback on what they know and what they don't know. One of the wrinkles here is that I typically encourage my students outside of class to work together on problem sets, so they can really collaborate and learn from each other well. On test corrections, I ask that they not do that. If they want to get any help on the test corrections, they're supposed to come in and see me during office hours. And what that means is that the students who did the worst, who probably should have been coming to see me during office hours anyway, are even more motivated to come in and get the help that they need as they're working through their test corrections. I'll add that I believe that this policy actually makes grading go a little bit faster for me. The first time I grade their tests, I don't have to write a lot on the exams because I want them to figure out what they did wrong and fix those errors. And then the second time, when I grade the corrections, typically we work through the problems and they get them all right. And of course, those are quick and easy to grade too. All right. So now let's talk about a few different structures for peer-to-peer feedback. As I mentioned, it's not always possible for one instructor to provide individualized feedback to every student in the class. And so sometimes it's more practical and also useful to have students practice during class, but then receive feedback from their peers on what they're learning and what they're practicing. So let's look at a few structures for doing that. One is the idea of peer instruction. We've talked about this earlier in the week in the context of clicker questions and peer instruction as a way to surface student misconceptions. Now I'll focus on the peer-to-peer piece of this. When you have students pair up and talk through a question together, it's a great opportunity for them, for lots of students in class, to get some peer feedback on how they understand things and how they're applying what they're learning. Now, you may wonder, during that pair discussion time, that peer-to-peer instruction time, are students actually learning during that process, or are they just kind of copying their friends' answers? And that's a question that a few researchers at the University of Colorado and the University of British Columbia wanted to explore. So this was a really interesting study that came out in 2009. The context was an undergraduate genetics class, and what they did was they developed a series of paired questions. So each pair of questions was what they called isomorphic. So they covered the same topic, they dealt with the same techniques, but they were different questions. So knowing the answer to one didn't guarantee that you knew the answer to the other, but they were similar enough that you could do some comparison. So what they did was they had students go through this kind of peer instruction sequence, and then they looked at how well the students did on these pairs of questions. And so you can see the results here. So in the first question of each pair, the average percent of correct answers across all the questions and students was 52%. Now, after students had a chance to talk about that same question, right, with their partner and then vote again, the correct response rate went up to 68%. Now, what's really interesting is when students were then asked the second question in that isomorphic pair, and they answered on their own without discussing it with their peers, the accuracy rate went up to 73%. So there were students who missed the first question in the pair, but thanks to whatever happened during that peer discussion, they were able to answer the second question in the pair accurately. I think this is pretty solid evidence that says that there's something really productive going on during that peer instruction phase, that it's not just kind of copycatting, but students are able to take what they've learned during that peer instruction phase and then apply it to a similar question down the road. Now, peer instruction is not the only structure for fostering peer-to-peer feedback. There are a variety of what are sometimes called challenge cycles in the literature that faculty have developed to try to foster this as well. This is one particular challenge cycle that was developed here at Vanderbilt, along with a few other institutions that were part of the VANTH project. This was a National Science Foundation funded project a few years back that involved getting educational researchers together with biomedical engineering faculty, looking at ways to create more evidence-based teaching strategies in biomedical engineering education. And one of their main kind of structures that they developed was this challenge cycle. So let me just kind of walk through it briefly. The idea is to start with an interesting challenge, a question that hopefully has some relevance to students. It's kind of a motivating problem. Students are going to have to kind of pull together a lot of information in order to solve that challenge. You start there. Then you move to this phase where you have students generate ideas, kind of a brainstorming phase. What do they know about this challenge? What do they don't know? What additional information are they going to need? That's often done in a kind of a combination of small group and large group settings. Then you move on to the multiple perspectives phase. Now, at this point, the instructor will then kind of share some additional information with the students relevant to the challenge, not solving it for them, but perhaps featuring maybe an article that's relevant or an interview with an expert that's relevant, giving students a few ideas and tools to kind of move them forward in solving the challenge. Then the students move into the research and revise phase. That's where they take what they've learned thus far and start to try to figure out some solutions to the challenge. And then they move into the test their mettle phase. Often this involves a prototype or a design of some sort, kind of a trial solution based on what they figured out so far. And then there's a go public phase. That's where they share what they've done with the rest of the class, typically. And then that leads into the next challenge, hopefully. This is a really nice structure. It leverages a lot of what we know about how people learn, and it involves a lot of peer-to-peer feedback along the way. Some of the feedback comes from instructors at different points in this, but a lot of it comes from within teams as they're moving through this challenge cycle. Now, you've probably experienced some real high-quality peer-to-peer feedback in your education. Often it comes in a somewhat structured peer assessment opportunity. These are some photos from an undergraduate biology lab here at Vanderbilt taught by Steve Baskoff. In this lab, students work in teams to do real research, actually. They have to kind of craft a research question and a research design and do some original research. At the end of the semester, they share their findings in a poster session. And during the poster session, students are asked to kind of walk around, view each other's work, ask questions, and give each other some feedback on this. You've probably been involved in some kind of poster session like this. There's other structures for peer assessment that are fairly common. So poster sessions are one. In-class student presentations often involve the students who are watching the presentation giving some feedback. If you have a writing component to your course, often there's some peer review of writing. These are all ways that we can help students give each other some structured feedback on what they're learning. Now, I want to end with a kind of one last principle and then a question that often comes up at this point. The principle is what I tend to call all skate. So let me tell you a little story. When I was in middle school, the thing to do was to go to the roller skate rink. Now, I was not much of a skater, but everyone was there, so I went there too. And I remember that the DJ, the announcer, would call out things like, "It's now couples skate time." And so if you had a date, you were encouraged to go out on the skate floor and skate romantically, whatever that means. I was typically not with a date, so I'd be sitting on the carpet during that phase. The DJ then might say something like, "It's time for the hokey pokey." And so you could come out to the middle of the floor and do a little dance. And frankly, you had to have a certain kind of skill level in order to do the hokey pokey on roller skates. So again, I was usually sitting on the carpet. But then the announcer would say, "It's all skate." And what that meant was that everyone in the whole place was invited to skate. You didn't have to have a date. You didn't have to have any particular skill level. You just needed skates on your feet. Everyone was invited to participate. And when I think of practice and feedback, I think of this all skate metaphor. That ideally what we want is all of our students getting a chance to practice and getting feedback. And so as you think about some of the examples that I've shared here, whether it's the clicker questions or the doodles or the Twitter example or pair instruction, the idea is to invite all students to practice what they're learning and to get feedback. Now, the question that I usually get at this point when I talk with faculty about these ideas is the question of really coverage is what it comes down to. How do you make time in a semester, particularly for in-class practice and feedback, right? This is time-consuming stuff. So how do you kind of fit that in a course? This can be particularly challenging in science courses that are sequenced. So there's a certain amount of material you need to cover in Chem 101 to prepare students for Chem 102, so you don't have a lot of flexibility in terms of time. Or if you're preparing students for external exams, like nursing exams, often there's certain stuff that you have to cover. And so if there's all this material to cover, how do you have time for the kind of active learning that we're talking about in class, providing students opportunities for practice and feedback? This is a tough question, right? In some classes, there's just not a lot of time for this. But I would argue that just because you're covering something doesn't mean that the students are learning it, right? You might get through a lot of material in Chem 101, but if students can't do anything with that, then it doesn't really help them that much in Chem 102 anyway. Now, when I talk to instructors about dealing with this challenge, there's a couple of kind of strategies or ways they think about it. One is that if you spend time early in the course with lots of practice and feedback, so that students are really learning that foundational material well, then later in the course they can actually move more quickly through the material because they've got the foundation solid. Another approach is to focus class time on the really hard stuff, on a day-to-day or week-to-week basis, and trust the students to figure out the easier stuff outside of class, either before class or after class, depending on how you structure things. Either way, I think instructors who are thinking along those lines are typically cognizant that you have a relatively limited amount of class time with students. A time and space where you're all there together. All the students are there, you're there. Again, students can do a lot of practice outside of class, and sometimes they can get a little bit of feedback outside of class, but the quality of feedback that they're going to receive in class is typically much higher because there's lots more people there who can help provide it. Peers, you. And so thinking about how to make use of the relatively limited class time that you have to give students the kind of practice and feedback that will really help them understand the material, that's taking advantage of class time really effectively. And often, I think, spending class time on practice and feedback and these active learning techniques end up preparing the students better for what follows than covering a lot of material.